Hi, I'm Matt Dirjish, Executive Editor with Sensors Magazine, and we're here today at Sensors Expo 2015 in Long Beach, California. I'm sitting with John Austin. He's a Product Marketing Manager for Analog and Interface Products at Microchip, and he has a very, very interesting device here. It is a high-side current power sensor, and it is the world's first to feature both an analog configurable analog output and two-wire digital bus. John, could you tell us a little bit about the chip and that two-wire interface? What is so interesting about that?
Sure. So the PAC 1921 is a high-side current sense amplifier that utilizes an I2C interface as well as a configurable analog output to communicate power information to the system. You can get power, current, and voltage information over the analog output, as well as have access to many other integrated features through the I2C bus. So I think that's one of the key values to the I2C interface, is it enables us to integrate features that the customer can access to maximize the performance of their system.
Mm-hmm. With that kind of versatility, I guess there's a lot of applications for this device.
There are. The fact that the device operates from 0 all the way up to 32 volts makes it suited for a lot of applications, low voltage applications, portable handheld devices, battery powered devices, all the way up to automotive to industrial type applications.
Mm-hmm. You mentioned earlier that during a demonstration that there was a very good application in computing. That's what you're a little bit noted for, but you know, it's a very versatile chip that it can go beyond that.
Right.
In terms of computing, what type of computing applications are we talking about? Well, cell phone, laptops?
Yeah, it
tablets?
could be both. I mean, so if you think of battery-powered systems, if you just using computer as an example, there's a lot of different power supplies within the system. They care about current consumption to extend battery life for, say, a laptop. Mm-hmm. They want to know what subsystem within the system is drawing the power. The PAC 1921 can be configured to give them all that information so that they can optimize the performance of their system. Mm-hmm. So it is well suited in computing. We've had success there, but really it extends far beyond just the computing as far as applications.
Excellent. Judging by the high level of integration in here, one could certainly put together a fairly sophisticated power management system using this chip.
Right.
And also I understand it's very tiny.
It is. It's in a 3x3 QFN package.
Would you happen to have a demo of that available on
a
demo board?
I do.
Could we see it?
We can.
Oh, great.
So this is the PAC 1921 demo board. The first thing that you should note is all the ICs on the demo are actually from Microchip and manufactured by Microchip. So this would be the PAC 1921. Down here we have the MCP 2221, which does the USB to I2C to communicate between the PC and the PAC 1921. And then we have a couple of MOSFETs that generate a current source, a programmable current source that we can use to drive a current across the shunt. So just a really quick overview of the demo. The quickest way to get it running is actually just to hit function F2, and that will open up basically this calculation tab, and it puts it in a free running mode so that it's always converting data and displaying it in this tab. So this gives you basically the bus voltage, the current and the power, and it also shows you the information in the accumulation registers. So down in the bottom left corner, you can see where you can adjust the voltage across the shunt. So you can do that either via this knob, I can turn it, or I can just type in a value. So I'm just going to put in 40 millivolts. And then up here are the tabs that actually show the data logs. So if I click on, say, the V bus, you can see that the bus voltage is at about right under 5 1/4 volts. And the sense voltage, you can see where I made the change, sitting right at 40 millivolts. And again, so if I change, I can tune this to different values, and the current sources change the current to generate that value across the sense resistor. And then here, this shows the power calculations. So the other features that we discussed during the presentation would be the ability to change the resolution for the current and the voltage. So you can select those up here. You can select different current gains and voltage gains. So again, current gain up to 128 and voltage gain up to 32. And then this would be to enable or disable the internal digital filters. And that's pretty much it at a high level. So one of the most unique things about the PAC 1921 demo, and what I think is one of the most useful things, is when they designed it, they made it very modular. So I can connect here to an external I2C, my system to the I2C bus, bypassing the USB to I2C converter that's communicating from the PC and communicate directly to the PAC 1921. That way I can actually implement it in my system to evaluate it. And I can connect an external load through these connectors so that I can emulate either my system load or even connect my actual system load to the PAC 1921. And then I can bias everything up through this connector so that they all are on the same ground plane and it's at the same ground as the system I want to evaluate it in.
John, thanks for that wonderful demo. Quick question, our readers and everybody out there is very price conscious these days. Could you tell us what kind of package the device comes in and what it costs?
Yeah, the package is a 3mm by 3mm DFN, and the web pricing is $1.18 and 5K volumes. And you can find the device at www.microchip.com/PAC1921.
Great, and it's available now?
Available now.